Hello and welcome to Chemistry Talk. I'm Hunter and today we'll be discussing percent composition and the empirical formulas and molecular formulas and how to find them. So first thing we're going to do is this first problem here. And the problem says to find the percent composition of adrenaline given that the compound of adrenaline is C8H11NO3. So first step here is to find the molar mass, and you do that by, multiplying by how many atoms you have of each by the molecular weight. That's a separate video I've done. But you get the total mass here to be 169 grams. So now when we want to find the percent composition, we want to find out how much each element contributes to that total mass. So to find the percent carbon, you would take the moles of carbon that you have, 8 moles, times its weight, and divide it by the total weight of the compound, 169 grams, and multiply by 100 to find the percent. So you find that to be 56.8% carbon. Same for the rest of the elements. For hydrogen, 11 times 1, because each one weighs 1 gram, over 169 times 100, and you get it to be 6.5% hydrogen. Not that much. Moving along for nitrogen, you only have 1, and each one weighs 14 grams, so it's just over 169, the mass, times 100, and you get 8.3% nitrogen. And then finally, we have oxygen. We have 3 oxygen, each weighing 16 grams, over the total mass times 100, and you get 28.4%. So this is your answer here. This is the percent composition of adrenaline. And if you were to add these numbers, you should get 100. Plus or minus 100 by maybe 0.2. But if you're like at 98, then you did something wrong. You should be 99.8, 100.2, somewhere in between there, or exactly 100 in this case. So that's the percent composition, and we're going to use our tools of how to find percent composition when finding the empirical formula. So our next question here says that we have beta-carotene, the building block of vitamin A. We want to calculate the empirical and molecular formula for beta-carotene. The compound's 89.49% carbon and 10.51% hydrogen by mass, and it gives us its molecular weight, which we'll use later. But, finding the empirical formula has a couple of steps to it. They're not hard, just have to remember what to do. So you have 89.49% carbon. Now, this could be considered grams of carbon, but we really want to find the moles. How many moles of carbon are in this compound, or in this percent? So we divide by the molecular mass of carbon, and we get 7.54 moles of carbon. Now we're going to do the same thing for hydrogen. We have 10.51% hydrogen, or you could say, grams, but I'm just going to keep it with the percent. And each one weighs 1.008 grams, so we get 10.43 moles each. So I'm going to bring this down here. 7.45 moles of carbon and 10.43 moles of hydrogen. Next step, different color. You divide by the smallest number. So in this case, we only have 2 numbers. 7.5 is smaller, so we're going to divide by the smallest. And now we get 1 mole of carbon, and we get 1.4 moles of hydrogen. Now, we can't round this number because it has to be within 0.2 with empirical formulas. So what we need to do is multiply and find a multiplication factor that will give us rounding of 0.2. But we have to multiply each. So I'm going to try 2. 2, 4, 6, those usually work. So 1 times 2 is just 2. And 1.4 times 2 is 2.8, is 2.8. And that we can round to 3. So the empirical formula of this beta-carotene vitamin A is C2H3, and that is the empirical formula. Now we're not done. It wants to know the molecular formula, but it's giving us the molecular weight of 536.89. So we know that it's giving us the molecular weight of 536.89 grams per mole, but I want to find out how many times the empirical weight goes into the molecular weight in order to find the molecular formula. So we need the empirical weight. So 12 times 2 is 24, plus 3 is 27 grams. So just did that math on the side there. So now we can find our molecular formula by doing this division, and we get 20. Now that is called the multiplication factor, because we're going to multiply the subscripts in our empirical formula by 20 to find the molecular formula. So the molecular formula turns out to be, well, 20 times 2 is 40, and 20 times 3 is 60. So C40H60 turns out to be our molecular formula. Now, that is the problem solved, but I'm going to go a little bit further and just talk about the difference between a molecular and empirical formula. So the difference, I'll just write it here, is the empirical formula is in simplest terms, meaning it's simplified. You can't simplify C2H3 anymore, but you can simplify the molecular formula. Well, let's try to do that here. So we have the molecular formula of C40H60. Let's divide by 2. We get C20H30. Let's divide by 10. We get, so divide by 2. Now we're going to divide by 10. We get C2H3. And look at that. That is precisely our empirical formula. So that's how they're related. Hope this helped you to understand percent composition and empirical formulas. Comment any questions or requests for videos. And